Here's another type of question you can get regarding mass spec. Equal in height, and they are 2 units apart. It's 108 and 110, right? So that's a molecular ion and an M+2 peak that are almost equal in height. And which halogen does that correspond to? Bromine, right? It's that easy, as long as you remember that. As long as you remember the isotope ratios. And knowing that that's bromine and thinking a little bit about fragmentation patterns, so you make a molecular ion, maybe bromine as an atom falls off, so the radical goes with the bromine, leaves behind an alkyl cation. And so once the bromine falls off, you're losing 80 and you're going down to here. Oh, wow, how about that? So it's actually losing 79 from the 108 peak, and it's actually losing 81 from the 110 peak. Both of those lead to 29. 29 is the mass of ethyl as a cation. Okay? Did you guys catch that? All right. Digging deeper with mass spec means looking at the fragmentation pattern and asking yourself, what's likely going on? Okay? So there are 2 common fragmentation patterns that happen. Actually, there are only 2 that you need to be concerned about. 2 ways you can break down. I already showed you the one. That's where your radical cation fragments into 2, one part being the radical, the other part taking the cation. The second pattern we haven't looked at is that some molecules like to liberate a neutral molecule. So a neutral molecule spits out. Now, if the radical cation, the molecular ion, fragments in such a way that a neutral molecule is lost, that means the neutral molecule takes neither the radical nor the cation with it. Therefore, both are left behind in the other fragment. And so it says that here. So you get the radical cation. Why ROH is in parentheses here is because this is very common for alcohols. Alcohols readily lose water as their neutral molecule. And then the new radical cation will often fragment further to give other peaks. And again, remember, there's a lot going on in a mass spectrum. You only need to interpret that which is necessary to solve the problem, just like with IR. Okay? So here's that other fragmentation pathway, where an alcohol is going to lose water. How does it lose water? See, that becomes the question. Now, this is regular chemistry, though. All right? Nothing in particular special here. So your initial ionization event, that's what's happening up here. An electron is lost. Now, a word of advice, I guess, I don't know. When you're considering which electrons in a more complicated molecule are likely to be lost, there's usually electrons that are more easily lost than others. And that all depends. You know, think about the energy diagram that we've looked at who knows how many times last semester. Electrons sit in energy levels, right? And usually the ones that are easiest to lose are the ones that are highest because they have less distance to travel to become a free electron. And so in the case of alcohols, the electrons that are most easily lost are the ones that are the lone pairs on the oxygens. They go easily. And so notice that in this ionization event, one of those lone pair electrons was lost. That gave it the positive charge, and now the radical cation. And I've labeled the MZ as 116, right? That's just the mass of the alcohol, and that's all there is to it. Now, how does it lose water? Right? Beta elimination. We looked at chemistry similar to this when we talked about the chemistry of alcohols last semester, right? And so the oxygen that's now a radical is able to abstract the hydrogen from the carbon next door, right? And so picking up that hydrogen allows it to become water. Water is then lost. Now realize it's radical chemistry too, right? So the oxygen is only missing one electron. So when it abstracts this hydrogen, only one electron goes with it. The other electron falls back onto the carbon, leading to this intermediate. All right? And then once that's formed, water leaves, you're left with a radical cation. The new molecular weight is 98. So, 116 minus 18, you get 98. Water, being a neutral molecule, is not seen by the instrument, but this one is, the radical cation.